It works on the principle of Pascal's law. Construction. There are two cylinders, a small cylinder C1 and a large cylinder C2, which are connected by a tube. The cylinder C1 is fitted with a piston which is connected to the brake pedal. The cylinder C2 has two pistons which are connected to the brake shoes. The cylinders and the tube are filled with oil. Working. According to Pascal's law, when the pedal is pressed, the pressure is transmitted to the cylinder C2. As a result, the brake shoes press against the disc and stop or slow down the moving vehicle. Uses. It is used in automobiles to slow down or to stop the moving vehicle. Hydraulic jack. Principle. It works on the principle of hydraulic press. Pascal's law. Construction. It consists of two cylinders C1 and C2 fitted with watertight pistons P1 pump plunger and P2 press plunger. A narrow tube connects the two cylinders. A platform is fitted at the top of the piston P2 over which the car to be lifted is kept. There is valve V in between the two cylinders. Working. The car is placed on the platform above the piston P2. A small force is applied to the smaller piston P1 by means of a handle H. This forces the liquid into the larger cylinder by opening the valve V, and piston P2 is raised. Once the car reaches the desired height, the handle H is released. The valve V closes automatically and keeps the platform in the same height. Uses. It is used to lift heavy loads and automobiles such as cars, etc. Hydraulic press, Bremer press. Principle. It is based on the principle of Pascal's law. Construction. It consists of two cylinders C1 and C2 fitted with watertight pistons P1 pump plunger and P2 press plunger. A narrow tube connects the two cylinders. A platform is fitted at the top of the piston P2 over which the materials to be pressed is kept. There is a rigid rod above the platform which acts as a roof. The material is compressed between the roof and the platform. There are two valves V1 and V2 at the bottom of the cylinder C1 and C2, which always open outwards and allows water to flow in one direction, that is, upwards only. Working. When the piston P1 pump plunger is raised, water enters into the small cylinder C1 by opening the valve V1. When the pump plunger is moved downwards, water is compressed and the valve V2 opens and allows the water into large cylinder C2. According to the Pascal's law, the pressure applied at the pump plunger is transmitted to the press plunger and the platform is lifted. The material which is kept over the platform is compressed between the platform and the roof. Uses: it is used for pressing bales of cotton, paper, metal sheets, and to extract oil from seeds. Hydrometers. These are very simple instruments used to find RD of a liquid. No additional apparatus like balance is required. These are two types: constant weight or variable immersion type, constant immersion or variable weight type. Principle: when a body floats, its weight is equal to upward thrust due to immersed portion. Constant weight, variable immersion type. Construction: it consists of a glass tube A of uniform bore. The lower end of tube is connected to a hollow bulb B. Lower part of bulb is connected to a small glass bulb L containing some load. Usually, load put is in the form of coal tar, mercury, or lead. Working: when put in liquid, hydrometer dips to different levels depending upon the density of the liquid. When lesser the density of the liquid, more it sinks, and vice versa. Stem A is calibrated to read density directly. Hydrostatics. The word hydrostatics has been coined by combining two words, that is, hydro and statics. Hydro means water and statics means at rest. That is, hydrostatics means water or liquid at rest. Therefore, the branch of science which studies the properties of a liquid at rest is called hydrostatics. Lactometer. It is a modified form of common hydrometer designed to test the purity of milk. Relative density of pure milk is about 1.030 and water 1.000. If the milk is adulterated with water, the RD will lie in between 1.030 and 1.000. Lactometer consists of gravity bulb increasing the length of the stem. Gravity bulb is filled with proper quantity of pitch. Marking M, 3m by 4, m by 2, m by 4 indicate full milk, 3 by 4th milk, half milk, 1/4 milk, and water respectively. Liquid pressure and thrust. Liquid pressure. Liquids have definite volume, but they take the shape of the container. Thrust. The force exerted by the liquid normally, perpendicularly, and acting on the entire surface is called thrust. The SI unit of thrust is Newton. Since thrust has both magnitude and direction, it is a vector quantity. Pressure. Liquid pressure is due to the thrust, which is acting uniformly throughout the liquid. Pressure is the thrust acting on unit area. Pressure is equal to thrust divided by area. Pressure acts in all directions. It is a scalar quantity. The SI unit of pressure is N divided by meter square. Pascal's law. Pressure applied on an enclosed liquid is transmitted equally in all directions throughout the liquid. Pressure at a point inside a liquid. A liquid exerts pressure at every point within it. Consider a liquid of density D at rest. Let us now find out the pressure at O at a depth h below the surface of the liquid at rest. Let us consider a small circular area A around a point O at a depth h below the free surface of the liquid at rest. An imaginary cylinder is constructed over the area. Since the area is very small, the thrust acting on this area may be taken to be uniform. Now, the force acting on this area will be equal to the weight of the liquid column over it. Area of the liquid surface at the point is equal to A. Depth below the surface is equal to h. The volume of the liquid column is equal to area multiplied by height, equal to A into h. Mass of the cylindrical liquid column equal to volume into density, equal to A h into d. Weight of the cylindrical liquid column equal to mass into acceleration, equal to A h d into g. Thrust acting over the area A equal to weight of the cylindrical liquid column, equal to Ah d g. Pressure at O equal to thrust by area, equal to Ah d g by A. P equal to h d g Pascal. Principle of hydraulic press. Consider two cylinders C1 and C2 of cross-sectional areas A1 and A2 such that A1 is less than A2, connected by a narrow horizontal tube T. Watertight pistons P1 and P2 are inserted in both the cylinders filled with a liquid. A weight of W1 kilogram weight is placed on piston P1. Let the force exerted on the piston P1 be F1. The pressure exerted at P1 is equal to F1 by A1. According to Pascal's law, this pressure is transmitted to each point on the liquid in C2. Let F2 be the force exerted on the piston P2. Therefore, F2 is equal to pressure on P2 into cross-sectional area. F2 is equal to F1 divided by A1 multiplied by A2. Due to this force, F2, the piston P2 moves upward. To check the motion of piston P2, a weight W2 is placed on it. F2 is equal to F1 into A2 divided by A1. Since A2 greater than A1, then F2 greater than F1, that is W2 greater than W1. Thus, a small force on the smaller area can be used to exert a much larger force on a larger area. Relative density. Density of a substance is the ratio between the mass and the volume. In CGS system, it is expressed in G by cc, and in SI system, it is expressed in kg by meter cube. Density is equal to mass by volume. Relative density of a substance is the ratio between the density of the substance to the density of a standard substance. Relative density of a substance equal density of the substance by density of water. It has no unit.